Okay, I'm gonna redo this example because we probably went really fast in class. I want to make sure you guys get it. So a conical paper cup is 20, so here's a cone. Conical paper cup is 20 centimeters tall. Okay, so H is 20 centimeters and it has a radius of 10 centimeters. And the bottom of the cup is punctured so that the water leaks out. So there's water inside. Okay? And the water is leaking out at a rate of 16 pi over 3 centimeters cubed per second. So what is the rate that the water level is changing when the water is 4 centimeters? Okay, so let me write down what I know about cones and volume and then relate the variables. So the volume of a cone is a third of the volume of a cylinder. So pi over 3 r squared times h. And I know that the water is leaking out at a certain rate. So that means that they're giving me dv dt, and it's negative 16 pi over 3 centimeters cubed per second. And they're asking me for dh dt. Okay, I'll put it in blue. dh dt, what is that when h is 4 centimeters? So that means that at some point the water is going to leak enough so that the water level goes down to 4 centimeters. And then we're asked for what is that rate. Okay, well, I want you to notice something. There's no mention of r or dr dt when h is 4. So if I were to try to differentiate the volume with respect to time with the original equation, okay, let's say it's 2 pi r over 3 dr dt times h plus, and then just product rule here, pi r squared over 3 dh dt, and I try to plug in everything I know, there's no way I can solve for dh dt if I don't know what dr dt is, and that's not given. I'm not given dr dt, so I can't do this. So instead, what I'm going to do is I'm going to use the original dimensions of the cone to set up a proportion. R to H is 10 to 20. That means that 2R equals H, or H over 2 equals R, and get that original equation in terms of just H. So pi over 3 R squared, H over 2 squared, times H. So now I have a new formula for the volume of just this cone here, which is pi H cubed over 12. So this means that now I can solve the problem. Now I can take the derivative with respect to time, and I get 3 pi h squared over 12 dh dt. Now I can solve for dh dt, given that dv dt is negative 16 pi over 3. And then I have h over pi over 4 when h is also 4. So that means that dh dt is equal to negative 16 pi over 3 divided by this quantity, which is simplifies to just 4 pi. So times 1 over 4 pi, and I get negative 4 over 3 centimeters per second. Is it seconds? Yeah. Okay. So because we don't know, they didn't give us the RDT, we have to get creative, use proportions to get everything in terms of H, and then take the derivative and then solve.